In this video, we'll talk about Jdbc, which connects applications written in Java to relational databases like MySQL. Let's first look at the big picture. As we mentioned before, virtually all database systems use client-server architecture. The server part manages the actual data stored in databases. And if we want to access the data, we use a client application like MySQL Workbench, Adminer, and so on. So what about the applications we wrote ourselves? What if our applications want to store data in a database? Well, these applications are also considered database clients, and they will need a library to communicate with a database server. This library basically takes SQL statements from the applications, send them over to the server, then gets the results back. Different programming languages have different libraries for database access. In Java, the library is called Jdbc, stands for Java Database Connectivity. Jdbc consists of two parts. One is known as Jdbc Api. Jdbc API is part of JDK. When you install JDK on your computer, you'll get Jdbc API. This part is database system independent, meaning that regardless of what database system you use, whether it's MySQL or Oracle or something else, you can use the same API to access them, which is quite great. But of course, different database systems are really different. So behind the scene, there has to be something that communicates with a specific database system. And that part is called the Jdbc Driver. And it's usually provided by the vendor of the database system. When we set up our development environment, we downloaded a jar file from mysql.com and placed it in the lib folder of Tomcat. That jar file was MySQL's Jdbc driver. With that in place, we can write Java code that talks to a MySQL server. Let's first look at this example. This is just a servlet. There's no JSP involved, just to keep things simple. And as we are pretty familiar with servlet, there's a doGet method here, and this doGet method prints out some HTML to the response. And starting from here is the database part. It will connect to the database on CF3, and it will select some data from a table, and it will output the data to the response. So the first thing we do is to create the table in my database on CF3. So this is my CF3 database, and let's come here and let's copy over some SQL here. So now I have a table called items in my database, and the items table has two entries. One is called milk, price $3.89, two of them, and then the other one is beer, price $6.99, and we have one of it. And then let's look at the code. So the first part of the code is about making a connection to the database. So similar to connecting to a website, we would need to provide a URL for that connection. And if you look at this URL, you can see that it's very similar to a URL for a web page. Start with the protocol part. For a web page, the protocol is usually HTTP or HTTPS. But here, since we are trying to connect to a database, the protocol is actually Jdbc. It uses the Jdbc protocol to talk to a database. But of course, different relational database systems are different, so this part is known as the sub-protocol. So under Jdbc, we use the sub-protocol of MySQL, meaning that we are trying to use Jdbc to connect to a MySQL database. And then this part is the same as in a regular web URL, where we specify host and also optionally port. Host is cs3.calcitla.edu. This is where our databases reside, and we can omit port because it's using the default port for MySQL services, which is 3306. If the MySQL server is running on the port 3306, we can omit that. And then this part is the database name. So my database is CA3220 SCO31, and this completes the whole connection string, which is this one. And then in order to connect to a database, we also need to specify username and password. So this is my username password. And then we can call the driver manager.getConnection method to create a connection by providing the URL, username, and password. So now we have a connection. There are a couple of more things I want to mention about connections. First is that username and password can actually be specified as request parameters in the database URL. I would recommend not to do that because oftentimes passwords have special characters in them, and if you specify it as part of the URL, some special characters can mess up the URL. So I would recommend that you specify username, name, and password separately instead of as part of the URL. And secondly, the MySQL server on CS3 is configured to use an authentication plugin that is compatible with older versions of MySQL, in particular MySQL 5. However, in certain MySQL 8 setups, if it uses the default MySQL 8 authentication plugin, it may require some additional request parameters in the connection URL. So an example would be something like this, where you may need to specify use SSL is false and allow public key retrieval is true if the MySQL 8 server is configured with the default version 8 authentication plugin. But for the MySQL server on CS3, you don't need that. Okay, so now we have our connection. What do we do with it? Well, we can use it to run SQL statements, of course. In Java, that means we need to use the connection object and then call the method create statement. That will return a statement object, which we can then use to execute either query, like select star from items, or updates, like insert, update, or delete statements. So you may be wondering what's the difference between query and update, and why there are two different methods in statement, one for queries and one for updates. So conceptually, queries are read operations, meaning that they do not change any data in the database. We simply search, we simply retrieve data from the database. And the updates, on the other hand, are write operations, meaning that they change the content or the data in the database. And for queries, that will be something like a select statement. And for update, that will be something like update statement, insert, delete, and so on. The reason JDBC treats these two things differently is because they return different things. In particular, if you think about it, a query returns a table or table-like data structure, right? Table. Let's just call it a table. For example, if you say select star from items, it will return something like this, where you have a table with name, price, quantity, and the number of entries. On the other hand, updates returns a number. In particular, it returns an integer number. And this integer number tells us the number of rows affected by the update operation. For example, if you insert one row, it will return 1. If you delete 10 rows, it will return 10. So because Java is a strong typed language, meaning that we have to specify the type of the return value by either query or update, Java has to handle query and update differently because they return different things. So if we look at the code here, we created a statement and we use a statement to run a query, and then we get some results in the form of a result set. So what about those results? Conceptually, we can think of query results as a table, as we just mentioned. The results will have a number of rows, or sometimes we also call them records, and each row has a number of columns, and sometimes we also call those attributes or fields. The columns have also names, or in other words, in addition to data in the results, sometimes we also got, excuse me, not sometimes, the result set also includes some metadata about these results. So in a programming language, a table can be represented as a list of records or array of records. However, it is very important to understand that in JDBC, query results are not a list or array. The reason is that the results of a query can be very large. If we keep it all in an array or list, it could take lots of memory space, which is very inefficient and sometimes can even crash your server if the query result is very, very large. So the Jdbc Result Set API is designed to access results one by one rather than all at once. As shown in this figure, you can imagine that there's a pointer, often called a cursor. At the beginning, the cursor points to before the first record in the result. Whenever we call the method result set next, like here, the cursor moves down one row, like this. So result set.next will move the cursor down one row. And the next method will return either true or false, depending on whether the cursor is pointing to a valid result or not. If it returns true, we can then access the columns inside this current row or record. And if we keep calling next, at some point, we'll run out of results, and at that point, next will return false, and we know that we can stop. Because of the way result set works, this is a typical code we use to process results. If the result has more than one record, we usually use a while loop and simply calling result set next until we exhaust all the results. Next will return false, and it will break out of the while loop. And this is in fact what we are doing here. Alternatively, if you know for sure the result only contains either one record or no record, for example, if you select something using its primary key, then either that record exists or not, and you know for sure there won't be more. In that case, you can use an if statement, and if it returns true, you know there's a result, you can process it, and if it returns false, you know the query returns no result at all. So either a while loop for multiple results, multiple rows in result, or if loop or if statement if the result has either one record or no record in it. So we can use result set next to iterate through each row in the result. But how do we access the columns in each row? Well, that's where this getSomething methods come into play. So when the cursor is pointing to a particular row, we can use this getSomething method to retrieve the values of the column in that row, either by using column name or by using column index. If you look at the API, you can see that there are quite a lot of those getSomething methods. You can get the column value as an array, or as a ASCII string, or as a big decimal, or as a blob, or as Boolean, as a byte, and so on and so forth. So basically, you have to tell Jdbc what type that value has, and it will return the value of that type. So this one basically says, give me the value of the name column as a string, and give me the value of the price column as a string. Actually, it shouldn't be a string. It should be something like a double, but just to make the point that you can specify type, and it will return it as the type that you specified. So this allows us to get the individual values of the individual columns of the current row. And of course, since we're doing it in a while loop, it will give us everything in all the results. And knowing that, if we run this, we can see that it did get all the values from this table. And here we are using column name, and we can also use column index. Column index starts from 1. So if we change this, for example, to column index 2, and it will show price, and in fact the result should show price twice, because this one is the same as getting price. So if I refresh this, we can see that it indeed shows price twice. This one is getting value by column index, and this one is getting value by column name. And in addition to the data, we can also get some metadata out of a result set. In particular, we can get the column name or column alias if we want, using result set get metadata and then get column name or column label. And then the last part of the code So one of the annoying things in Java is handling exceptions. Many JDBC methods throw SQL exception, which we have to try and catch. Whether there's an exception or not, we want to close an exception, but closing an exception may throw an exception itself. So there's another try and catch just for closing an exception. And you can, in order to properly handle exceptions, we have to have code like this, which looks kind of ugly, but this is what we need to do. Okay, so speaking of exceptions, one common error people encounter in this class is an error that says too many connections to the server. This is because each class account is limited to at most 4 concurrent connections to the server. So remember to close a connection when you are done using it. And very importantly, don't use multiple tabs in MySQL Workbench, because in MySQL Workbench, each tab will take up 1 connection. If you open up 4 tabs, your code won't be able to connect to the server anymore. Okay, so now we know the basics of JDBC, starting from creating a connection and then execute statement and then iterate through the result set and then catch and handle exceptions. Let's go back to our guestbook example, and this time we'll do it with a database. So first of all, let me stop the server. And by the way, in case you don't know this, if you expand the server, you can see all the projects currently deployed on the server. I've seen people have lots of projects deployed, and every time you run a new project, all those previous deployed projects will also get started, and it makes running the current project pretty slow. So what you want to do is click here to expand it and then remove any old projects that you don't want to run anymore. So now come back to our guestbook example. I have already made a copy of the MVC version of the guestbook. So here, if I run this, let me close this one. Here, if I run this, so it already works. We can do Tom and says hi and so on and so forth. And this is the MVC version. The way it works is it stores data in application scope, and anytime we add something, it adds to the application scope and so on and so forth. And now we want to use the database, of course. So let's see first what do we have for guestbook entry. Okay, so the first thing we probably should do is change the model class a little bit. We no longer need to generate IDs ourselves because the database will generate ID for us. So here we will do something like this. Actually, we probably don't even need this one anymore. Let's just have an empty constructor. we'll let the database to generate unique IDs, which is much better than doing it ourselves. And then we'll need to do something with this and then this. Okay, let's first do something with this. We no longer need to store data in application scope, so we can get rid of all of this. And however, we do need to get data from database. So we'll change this sometime later. And this one, instead of doing this, we'll need to say insert data into database, and so do something about that later. Okay, so right now at least we have fixed all the syntax errors. Now, then we of course need to have our database, and each guestbook entry has ID, name, message. So let's come here, and we'll say create table guestbook, and we'll say there's an ID, which is an integer, which is auto increment, which is a primary key, and then we'll have a name. Let's say name is varchar this much, and what's the third one? Message. Message. Okay, so message will be a little bit longer. So let's say message will be 8,000. And let's run this. So now we have our guestbook, and then let's insert a few things into it. We'll say insert into guestbook, and the name message will be values, and John says hi, and Jen says hello. And if we select, we have John and Jim. Okay, great. And then come back to guestbook. So we need to do this. And we know how to do this because we just had an example here. And let's grab all this code. Let's put it here. Okay, so we connect to the database, and instead of selecting star from items, we are going to select from guestbook, and then we will iterate through the result set. Instead of writing out everything to response, here we want to create a list of guestbook entries, and then pass it and then actually we don't need to do close here since we have a finally close here. So we'll say pass the list to view, and that means we'll have a guestbook entry here, guestbook entry, and then here we'll say something like guestbook entry is new guestbook let's say entry.set ID is rs get int ID, and entry.set name is rs get string name, and entry set message is rs get string message, and then of course we need to add it to entries, and then we will need to do a request set attribute entries and then entries. Okay, so that should do it. Let's run this and see if it works. Okay, so let's come back to this and refresh. Okay, so it has John says hi and Jane says hello. So sorry about that. Let me silence my phone. Okay, so now the first part, the display part works, and this I think is also a good example of showing the flexibility of model view controller architecture. So as you can see, we didn't make too many changes. Our model is pretty much the same, except that we no longer even need to generate unique IDs ourselves. And our view remains the same because it doesn't really care whether the data comes from application scope or request scope. The only change is in the controller, and instead of maintaining the data in application scope, now it gets data from the database, and the rest remains pretty much the same. So model view controller architecture is good. Let's do the add comment part. So in add comment, we have doGet, which will display a view, which display a form, and we want to keep that. And then we get the name and message, and then we want to insert it into database. Here, let's implement this part. So insert data into the database. Let's once again grab some data from here. And we have the connection, we have a statement. Here, instead of trying to execute a query, we're going to try to execute an update. So let's create an update. The update will be something like this. We'll say insert into guest book value name and the message, and then values. We'll need to put name and message into quotes. So it will be something like this: a single quote plus name plus another single quote, and then comma, and another single quote plus message plus another single quote, and then closing parentheses. Something like this. We'll see if it works. And then we'll do statement execute update, and then that's pretty much it. Yeah. And once we are done, we redirect the user back to the view, back to display. And let's run this code and we'll say add comment, and we'll say Tom says hello. It seems to be working. Let's come to here and check, and it does insert Tom says hello. So we can do the same for edit and delete. I'm not going to do that in the video. You can do delete and edit as an exercise, or you can also check out the example later. I'll add the code later on. Here let's do one more thing. So notice that here the database automatically generated an ID for the entry Tom, and that's because we when we created the database, we set the ID primary key auto increment. But what if we want to get this ID back? In this case, we don't really need to get the ID back, because right after we insert the data, we just do a redirect. However, in some certain cases, you do need to get the ID back, and you can do that by specifying an additional argument when you try to execute an update. So it's something like this. If we want to get the ID back, instead of just saying execute update here, we'll add a second argument. Let me quickly check the API documentation. The second argument is one of the following constants statement return generated keys. Okay, so we'll want this one. And so after the execute update, it will return the generated keys. And what we do with that? And then we need to use a result set. We'll say result set. Doesn't really matter what we call it, and we'll say statement and get generated keys. So this will return all the generated keys. Notice that because a SQL statement can affect multiple rows, so it actually returns the generated keys as a result set, and then we will have to iterate through the result set just as before. And since we know there's only one keys generated, we can simply do a result set next, and then we can say, let's just print it out and see. System.out.print rs get int. It should be the first in the first column. Let's see. And let's come back here and refresh and add comment, and let's say Jim says like your site, and so notice that it prints out 4 here, and that's the ID generated from the database. Occasionally, if you want to get the auto-generated ID, this is what you can do. Okay, so moving on, as you can see, if the application is already in MVC architecture, the changes from using application scope to database is not a big change. It's relatively straightforward. The code doesn't look very nice, but you can do some optimization by, for example, taking all this code and put it into a separate class, so your controller can use that separate class commonly referred to as a service class or service layer to access a database and then simply return, for example, a list of entries, get book entries, and so on. So those are common programming practice that you can use to improve how the code looks. What I want to talk about here is something more directly related to database access, and that's handling special characters, which could potentially lead to more serious security problems, known as SQL Injection Attack. So what I mean by that is our code right now kind of works, but if, let's say, there's a person whose name, let's say, is O'Brien, and if O'Brien leaves a message, whatever that message is, we're going to get an error. And this error will say you have error in your SQL syntax, and it happens at line 62 of add comment. So if we look at line 62, it's an exception. So what happens before that? Yeah, it's actually here. The root course is 55, and 55 is here. Okay. So the SQL will cause a syntax error, and the reason for that, if you look at the SQL, you can kind of tell, because we create the SQL statement using string concatenation, and we actually use single quotes in order to create string literals in SQL. If the name itself has a single quote in it, like the name O'Brien, for example, it will basically break this SQL statement and cause a syntax error. This can become something quite a bit more serious, known as SQL Injection Attack. So in a SQL Injection Attack, a bad guy can specifically craft a special input string. Well, not O'Brien, but something similar. And that special input string can potentially change your whole SQL statement. And that, of course, is a big security risk. So let's see this example. So again, let me stop this one, and let's remove guestbook Jdbc for now, and let's run this SQL injection attack example. Where is it? It's here. Let me close everything. First of all, let me create a table in the database first. Okay, so now in our database we have an employees table, and this employees table has some, let's say, employee information. Each employee has an ID, username, password, and it also has some sensitive information like the birthday of the employee, the salary of the employee, and so on. So let's say that we want to create an application where each employee can see their own information but nobody else's information. So this would be something we build. We are going to do MVC, of course. The model class will be an employee class with ID, username, password, birthday, salary, corresponding to the columns in the table. And then we will have controller, and this controller will display a form. Let's run this. Now, in this form, we'll ask the employees to provide their username and password. And then in doPost, we'll do a query using their username and password. We'll say select star from employees, where username is whatever username they provide, password is whatever password they provide. And then we'll display the results. And the intention is, of course, only if the user provides the correct username and password, this query will return any result, because otherwise the where clause will be false. So for example, if I say John and ABC, we say John and ABC, so this code may be a little bit old, and I think we probably shouldn't have this part here. And oh, it's because of this. It should be localhost. It should be cf3 la.edu, and this is the username and password. Okay, so this time it should work. I forgot to change the code to point to the cf3 server. And let's run this again. Okay, so let's say we do John and ABC, and we see John's information. And let's say we type John's password 1 instead of ABC, we say ABCD, and we got no information. So this is how the application is intended, but because of the way we construct our SQL query, we are subject to the so-called Sql Injection Attack. What that means is, suppose I'm a bad guy and I don't know any username or password, so it doesn't really matter. I can type some random things. But here's the trick. I'm going to put a single quote here, and then I'll say or, and single quote, and equals to this with no single quote afterwards. Now, if I do this, I can get everybody's information without knowing any username and password. The reason for that is, of course, this trick. Notice here the way we construct the SQL statement is by doing string concatenation, and we are going to concatenate username and password with a bunch of single quotes and so on. So if we take this and try to put this one in, what we'll end up having is something like this. What we'll end up having will be select star from employees, where username is this. Of course, nobody has that username, but we'll also have password is this. So now you can see that by creating a weird looking password, which is this part, we actually changes the whole SQL statement. Instead of saying where username and password must match this, it's basically saying it can be username is this and password is this, or 1 equals to 1. 1, of course, always equals to 1, so this one is always true, regardless of what you put for username password. And because this is our OR operator, and the whole where clause is always true no matter what. So this way, although we don't know any username password, we can get everybody's information. And this is known as Sql Injection Attack, which is a very serious attack. A few years ago, this is the #2 ranked web attack, I think just below social engineering. So very serious, very commonly used, and need to be mindful, avoid preventing SQL injection when you develop web applications. The good news is that in Java, there's actually a very easy way to prevent SQL injection attack, which is to use prepared statement instead of statement. A prepared statement looks like this. You'll first specify a SQL statement with placeholders. So for placeholders, you use question mark, and then you call prepare statement and specify this SQL string, and it will create a prepare statement with a few placeholders. And then later on, you can fill in the placeholders with actual value, and you can say the first placeholder should have the string value of orange, second one should have the big decimal value of 0.59, and the third one should have an integer value of 4. And then you run the update. So the main benefit of this is that when you have strings, the Jdbc driver will ensure that all the special characters in strings, like single quotes and everything, are properly escaped, so that nobody can change the whole SQL statement simply by using some special characters. So let's see how this works. Coming back to the guestbook example, and here, instead of using statement and create something like this, we are going to use prepare statement. So the SQL will look like this. It will say insert into guestbook name message value question mark, and then question mark. So as you can see, an added benefit of using prepare statement is that your SQL looks much more readable comparing to creating the SQL statement using string concatenation. And then we'll change this to prepare statement. And we'll say prepare statement SQL. And then we'll do p statement set. So we'll say set string. The first placeholder, it should be a string, and we put name in it. And we say p statement set another string to the second placeholder, and it should have message in it. And then we say p statement execute. And we no longer need to have the SQL here because we already specified SQL there. And for p statement, for prepared statement, if we want to have the return generated key, how do we do that? Let me so we still need to have the SQL there. Okay, so let me put it there. Okay, and then this will execute the statement, and then we'll say p statement get generated keys, and then okay. So let's see if it works. Let's run guest book. And this time we'll say Brian, and has a special character single quote in it, and say I like your site, and add. And so let's see. Insert into guest book name message and values question mark question mark. Looks good to me. Why is complaining? Let me see. I think it's trying to execute the original rather than the... Yeah, so let me comment out this line first. And let's just do p statement execute update. Okay, so let's try this. Refresh and add comment, and then offline says I like your site. Okay, so this time it works. I think I have some problem with getting the generated back key back in prepare statement. We'll check the API documentation in a moment. So if we look at the guestbook, we can see that now a single quote is handled properly when we use prepare statement. Let's very quickly check the API for this one. Oh, okay, I got it. The auto-generated key should be used when we prepare the statement. Okay, should be here, not when we execute this statement. Where is the code? Here. This part should be here. And then we can execute it as usual, and then we can get the result set. Okay, so this should do it, and then let's try it one more time. I thought it looks weird if we put the SQL inside execute. Anyway, and coming back, and well, let me refresh first, and this time let's say mainly, and it says hi. So it works here, and it also prints out the generated ID here. Okay, so that's pretty much about prepared statement. Prepared statement is really useful. It handles special characters, and it prevents SQL injection attack, and makes the SQL statement more readable comparing to string concatenation, and it actually gives you better performance, because when you say connection prepare statement, the query is actually parsed at that time. So later on when we'll run the query, especially if you need to run it multiple times, then it gives you better performance than the database having to reparse the query every time. So all in all, please use prepare statement, especially when part of a SQL statement comes from user input, like the add comment one, or like the username password for the employee one. In those cases, definitely use prepare statement, because otherwise you are making yourself vulnerable to the SQL injection attack. So that pretty much covers the basics of database access in Java applications. There are 3 subjects we won't cover, but they are important enough that I want to give them a quick mention. First is transactions, and the so-called ACID properties of transactions: atomicity, consistency, isolation, and durability. Transaction is a very important feature of relational database. It basically allows us to run multiple SQL statements together as one unit of work. We won't get into details about transactions since it's covered in database classes. But here, just very quickly, if you want to create a transaction in Jdbc, it's quite simple. Jdbc connection by default automatically commits after each SQL statement. To create a transaction, you just need to disable auto-commit in connection, and then run your SQL statements, and then issue a commit statement. Then all the SQL statements in between are considered as part of one transaction. Another thing is connection pooling. Creating a database connection is actually a very expensive operation. You have to send username password to the server has to verify the username password, and then send back a response. It's a very big overhead. In our code, we open a connection, run a few SQL statements, then close it. It's actually very inefficient. In practice, you would want to use a so-called connection pool. A connection pool can keep several connections open. Whenever you need a connection, you just grab one from the connection pool, and when you are done with it, instead of closing it, you'll release it back to the pool. There are several popular connection pooling libraries for Java. Tomcat actually comes with a connection pooling library itself. Check out the linked document to see how to configure it. And last but not least, there's something called object relational mapping, which kind of allows you to load and save data as objects instead of having to convert between objects and rows and columns, like what we are doing here, converting columns and rows back into objects. And here we are saving an object, but as a row instead of an object. And object relational mapping let you to treat objects as objects, basically, and even when you have to save them in a database. This is something quite useful and makes database development a lot more enjoyable. And we'll cover Hibernate and JPA for object relational mapping in a graduate class. Okay, so this is it for this video. See you in the next one.